Now, let me show you how we can build our serverless API. This is the CDK application that I have built for deploying serverless API. There are two files in this folder, CDK and Lambda functions. Obviously, Lambda functions holds all AWS Lambda functions that I need to run the API, and CDK is the CDK application. So let's review the AWS Lambda functions to give you a quick overview on how this API looks like. In Lambda functions folder, I have 4 subfolders, each respective to activity that I want to run for my API. They are list data, save data, get data, and delete data. So let's take a look into save data function. This function will be triggered if there's any incoming request with post method. It's going to get the JSON payload from the body and save the data into Amazon DynamoDB. Now, to get the list of all data, we also have another function, and that is called list data. In this function, for get request into the endpoint, it will load all the data from DynamoDB and return only the ID of the data. To get specific details from the database, we can pass the ID into getData function. Here, our app performs query into DynamoDB to load all the details based on the ID of the data that we'd like to get. And lastly, to delete the data, we also have delete data function. And this function will delete the data based on the ID that we pass as input. Now we know all the functions to run our API. The next step is to define the resources using IAC with AWS CDK. This is our main CDK application, and here's the fun begins. In this file, we define all resources we need to run serverless API. Here, we import all required libraries. We have AWS Lambda, DynamoDB, API Gateway, and other required libraries from CDK. This line shows this is a CDK application, and we're going to use this stack. If we go to the declaration, this leads us to the stack that we are going to use to define our serverless APIs. Let's review it one by one. The first thing that we are going to define in the CDK application is the database. The database in this serverless APIs is using Amazon DynamoDB. And this line shows us how to define the table using Amazon DynamoDB using this configuration, such as table name, partition key, as well as read capacity and write capacity. Now we need to create permissions for AWS Lambda to access DynamoDB. So here we define the IAM roles for our Lambda function. First, we like to have our AWS Lambda to access CloudWatch logs. So here we define the access to CloudWatch logs. Then we define the access to DynamoDB. We are implementing least privilege for our DynamoDB, which means that we are only providing few actions like put, get, update, and delete item, as well as scan, query, and checking with conditions. Now, with this role, it will not allow our Lambda to do any other than these defined actions, ensuring we have security in place. At this stage, we have our DynamoDB and IAM roles. In the next section, we define our AWS Lambda functions. The structure is pretty much the same. So let's review for save data function. The first thing that we define here is the code property. The code property refers to the asset code that we have. And as you can see, this is the path to the Lambda function folder, and it is located here. And this is really convenient, as we can code our infrastructure and code our applications without leaving our IDE or code editor. Next is the main handler function. In this case, it is called as app.handler. Then we also define timeout, and I set it to maximum 60 seconds. Also the role. This is important, as without this, our Lambda functions cannot run properly, as it needs access to DynamoDB and also CloudWatch. Here we refer to the Lambda role variable that we previously created. Then we activate tracing, and this also means we are enabling X-ray that's helpful for us to practice observability and monitoring. And lastly, runtime. I'm using Python 3.8. As these Lambda functions require to connect to Amazon DynamoDB, we also need to inject the table name as environment variable, which Lambda functions can easily load. And to do that, we can use add environment function to inject environment variable into AWS Lambda function. Its key value property, and I'm using table name as the variable name and the DynamoDB table name that we previously defined. And the same thing applies for the rest of AWS Lambda functions. So let's go to the next section, and that is Amazon API Gateway. To define the API Gateway, I'll be using REST API object from Amazon API Gateway. To integrate the REST API with our Lambda functions, we need to have integration. And in these lines, we have the integration for our Lambda functions and REST API object. And when it comes to REST API, we also need to define how our clients can access all the resources. So let's say that we want to have the client to access the resources using this URL. Then we need to define the data as the path. Then we define the method that we like to integrate with this resource. And sometimes we also need to pass the URL parameters. And we can do that by using this directive. This way, for any request to this endpoint, we'll go to these integrations. And lastly, we need to output the DynamoDB table name as well as the endpoint URL from Amazon API Gateway. Okay, so we have our CDK app ready. The next thing that we need to do is to deploy this application. To deploy this application, let's switch back to the terminal and run CDK deploy. CDK is now preparing all the assets and provision resources for us. And after CDK is done processing, we can see the outputs here. And that includes the endpoint URL from Amazon API Gateway and also the DynamoDB table name. And this shows us that we can easily integrate ISC and our applications using AWS CDK.